If you have watched my previous lecture, now you're ready to see how this paper, which is written by Allen Institute, can be used for decomposed prompting. So it's a generalization of some of the ideas that we have seen in the previous lectures. So you see, this playlist is very coherent, and all of these ideas are sometimes modification, and it's a development process. So what are the challenges of few-shot prompting? Few-shot prompting is a surprisingly powerful way to use large language models to solve various tasks. However, this approach struggles as the task complexity increases, or when the individual reasoning steps of the tasks themselves are hard to learn, especially when embedded in more complex tasks. So the Allen Institute for AI, they proposed decomposed prompting, a new approach to solve complex tasks by decomposing them, of course via prompting, into simpler subtasks that can be delegated to a shared library of prompting-based large language models dedicated to these subtasks. This modular structure allows each prompt to be optimized for its specific subtask, further decomposed if necessary, and even easily replaced with more effective prompts, trained models, or symbolic functions if desired. So this is the standard prompting. You see, it's just they are independent. But the chain of thought prompting that I explained in one of the lectures in this playlist is like this. But we can make it more general by kind of decomposed prompting, in which in each of these subtasks A, it could be a different vault. And then you have some subtask handler for each task, and then you combine them. And so this is the decomposed prompt. This approach has several advantages over prior work. The subtask handlers can be shown a broader and richer set of examples than the specific ones needed for the complex task prompt. If a subtask is too complex, it can be further decomposed into simpler subtasks. Similar to software libraries, these subtask handlers can be shared across multiple tasks. Here, task A and C are reused in the model for task B. As noted above, a subtask handler can be easily swapped with an improved implementation without any change to the rest of the system. Few-shot prompt-based large language models can be even replaced with a symbolic system for tasks more suited for non-neural methods. Task C uses a symbolic retrieval system, such as Elasticsearch can handle very large-scale corpora. Lastly, we can even improve upon prior work by simply adding an error correction subtask handler as a post-processing step. So, as with the conventional few-shot prompting, the goal is to teach a large language model to find an answer to a query using a small set of in-context examples. The answer is obtained from the underlying distribution. So in most basic few-shot setup, examples take the form EJ. So in Decomposed P, the core is a decomposer large language model that tries to solve a complex task by generating a prompting program for it. And each step of P directs a simpler subquery to a function in an auxiliary set of subtask functions. Given a query whose answer is A, the program P is a sequence of this form, where AK is the final answer predicted by P and QI is a subquery directed to a subtask function. To teach the decomposer large language model in a few-shot prompting manner, we use in-context examples. Each subtask function F is operationalized by a subtask handler as an in-context prompting large language model or any other symbolic or learned function. So, for example, consider this example. Concatenate the first letter of every word in Jack Ryan using spaces. First, we should understand what are the words, so we split it. This is the question 1. The second question is, now for each of them, we should go through and see what is the first letter of that for each of them. And finally, we merge them. And that's it. So this is how Decompose P iteratively calls the decomposer prompt to generate the next question. And hierarchical decomposition, certain subtasks, even when given many examples, are not solvable with few-shot prompting. We found identifying the case letter of a string to be challenging for GPT-3. In such a scenario, we can decompose the subtask prompt further to first identify the letters and their position, and then select the case element of this array. We can also reuse existing subtask prompts in our framework. For example, the split prompt can be reused since it was developed for the general task of splitting strings. And we have recursive decomposition. Some problems can be naturally broken down into one or more smaller problems of the same form. Recursive algorithms such as merge, sort, use this idea to solve large problems efficiently using a succinctly described method. For long context question answering, we then evaluated on the QAE dataset under the reading comprehension setting. The dataset consists of synthetically generated entities, so facts and multi-hop questions. So due to presence of many distractors, and as a result, longer context, this dataset has been shown to be hard for standard large language models, even when fine-tuned. And they use it for open domain question answering as well.